Good morning, another person here. I am Dr. Sriran from Civil Department, Associate Professor. Now I am going to take feedback amplifiers. Okay. Before going to the feedback amplifiers, now I introduce what is an amplifier. Amplifier is an electronic circuit which increases the input signal. The input signal may be current or voltage or power. Okay. There are three types of amplifiers. They are common base amplifier, common emitter amplifier, and common collector amplifier. Common emitter amplifier is most probably used in the real circuit. I draw the circuit diagram for common emitter amplifier. What is common emitter amplifier? Here the emitter is common between input side and output side. Now I am going to draw the circuit for common emitter amplifier. Emitter, base and collector. This is your input, this is your output. The input between base and emitter, and output between a collector and emitter. This emitter is common between output side, input side and output side. That's why it's called as common emitter amplifier. Here in this circuit, the R1 and R2 acts as biasing circuit, biasing resistance. RC and RL acts as load resistance, RE acts as stabilization resistance, then C in and C out acts as coupling capacitor, CE, this is CE, this is bypass capacitor. The capacitor allows AC only. Why it allows AC only? What is Xc? Capacitive reactant X is equal to 1 by 2 pi Fc. If frequency increases, Xc decreases. What is the frequency for DC? Frequency for DC is 0. That is anything divided by 0 equal to infinity. Therefore, it does not allows AC. DC does not allows. Capacitor does not allows DC, it allows only AC. That's why it is called as coupling capacitor. This is bypass capacitor. Okay, then this is common emitter amplifier. The input side is forward bias. Input side is forward bias, and output side is reverse bias. Why? This is your NPN transistor. P type is connected to positive of the battery and N type is grounded. Therefore, this is input side is forward bias. Here output side, this is N type. N type is connected to positive of the battery. That is why it is called as reverse bias. This is what is forward bias. P, you know the PN junction diode. Positive connected to P type is called as forward bias. P type, N type. P is connected to negative of the battery and N type is connected to this is called as reverse bias. If input side is forward bias and output side is reverse bias, then the transistor is operate in the active region. In this circuit, the transistor is in the active region. Okay, this is called as common emitter amplifier. In this common emitter amplifier, we are giving sine wave. You will get the output like this, inverted sine wave. That is 180-degree phase shift. 180-degree phase shift. How do you get this 180 phase shift? This is biasing required for this transistor. If the input is increases, the collector current decreases. If input increases, collector current decreases. If collector current decreases, if input increases, the collector current also increases. If the collector current increases, V0 will decrease. V0 will decrease. If input is decreased, IC decreases, Vout will be increased like this. That is why we will get 180 degree phasing. In this common amplifier, the input impedance is high, output impedance is high, gain is moderate. Both voltage and current gain to introduce feedback amplifier. What is feedback amplifier? Feedback amplifier is an amplifier. The part of the output is fed back to the input to get the desired value. That is called as feedback amplifier. Feedback amplifier. This is your amplifier. What is a feedback amplifier? Feedback amplifier is an amplifier. The part of the output is fed back to the input. This is your output. This is your input. Input. This is your output. This is your amplifier. The part of the output is fed back to the input. Beta is the feedback factor. A amplifier gain. Beta feedback factor. Okay. Here the input is taken as Xs, anything, power or current or voltage. X0 is your output. Xi is your input to the amplifier. Xf is the output of feedback network. Okay. What is A? A is equal to, what is A? Amplifier gain. What is gain? Gain is equal to output by input is called as gain. Okay. What is your output? X0. What is your input? Xi. X0 by Xi is amplifier gain. What is beta? Feedback factor. That is output. What is your output? Xf. What is your input? Xi. This is your beta. Okay. What is A? A is equal to X0 divided by Xi. At the same time, beta is equal to Xf divided by X0. I need X0. What is X0? A, Xi. Here, what is Xf? I need Xf. What is Xf? Beta X0. What is, you know X0? What is Xf? Xf equal to beta into A Xi, or it can be written as A beta into Xi. Okay. What is the overall gain of this feedback? That is called as AF. Amplifier gain X0 divided by Xi. What is your overall gain? This is X0. What is your input? Xs. Therefore, AF is equal to X0 divided by Xs. Okay. What is Xi? Input Xi is equal to Xs. There are two types of feedback. There are positive feedback and negative feedback. Okay. Here I am increasing negative feedback means Xi is equal to Xs minus Xf. What is Xs? Xi plus Xf. You know what is Xf? This is equal to Xi plus A beta Xi. Take Xi outside, 1 plus A beta. This is Xs. What is AF? AF equal to X0 divided by Xs equal to X0 can be written as AXi. AXi divided by what is Xs? A 1 plus Xi into 1 plus A beta. Xi get cancelled. What is AF? AF equal to A by 1 plus A beta. This is the overall gain of the feedback with the negative feedback. Here it is your input side positive, this is negative. This is called as negative feedback. Okay. For negative feedback, overall gain AF is equal to A divided by 1 plus A beta. This is negative feedback. Negative feedback. If it is what is positive feedback? In negative feedback, the input and outputs are out of phase. What is out of phase? If the input is in the positive direction, the feedback signal in the negative direction. This is called as negative feedback. Both are out of phase. Okay. Then, what is positive feedback? What is positive feedback? The input and output are in phase. The input and output should be in the same phase, then it is called as positive feedback. Same derivation. Here what is xi? Xi is equal to xi xs plus xf. That is equal to xi minus this one. Here you put minus, here you put minus, here you put minus, will get. For positive feedback, the overall gain is A by 1 minus A beta. This is for positive feedback and negative feedback. Now I am introducing block diagram of feedback amplifier. What are the networks used in this one? Feedback. Okay. And now I am going to draw the basic block diagram of feedback amplifier. This is input source. This is mixing network. This is called as sampling network. This is load output. This is amplifier A. This is called as feedback network. Okay. The input is positive, the mixing is called as plus or minus. Okay. A part of the output is fed back to the input through the mixing network. Okay. This is input source, this is a feedback signal. We are mixing this one in the mixing network, then it is going to the amplifier. What is sampling? A part of the output is fed back to the sample, that is called the sampling network. Okay. This is basic block diagram of feedback amplifier. Okay. Then there are different types of feedback. That is positive feedback and negative feedback. If it is positive, both input signal and feedback signal are same phase, then it is called as positive feedback. If input signal and output signal are out of phase, then it is called as negative feedback. Okay. What is feedback? Overall feedback amplifier gain of overall feedback in negative amplifier, that is A by 1 plus negative feedback by 1 plus A beta. If it is negative feedback, if it is positive feedback, A is equal to 1 minus A beta. These negative feedbacks are used in amplifier, then positive feedbacks are used in oscillators. Okay. In negative, what are the next one? What are the features of negative feedback? What are the features of negative feedback? features of negative feedback. First one, you know the overall gain AF is equal to A by 1 plus A beta. If beta increases, A will reduce. So first one, gain reduced. Second one, input impedance or input resistance decreased. Input impedance increased. Output impedance decreased. Noise reduced. Distortion reduced. Bandwidth increased. And the last one, stability improved. These are the main features of negative feedback amplifiers. Again, you know the common emitter amplifier without feedback. The frequency response is like this. This is gain. Sorry, this is frequency. This is gain. Frequency versus gain graph. This is without feedback. Without feedback. With the feedback, the response is like this. Okay. You know, lower cutoff frequency, upper cutoff frequency. For you have to draw the 3 dB line. This is EFLF. This is upper cutoff frequency, higher cutoff frequency. Okay. Input impedance may be increased or decreased based on your types of feedback. Output impedance also same type. Then noise and distortion always decrease, gain decrease, bandwidth will increase. Here this is the bandwidth for common emitter amplifier or any amplifier. This is feedback bandwidth for with the feedback. Bandwidth without feedback. Without feedback is FH minus FL. For bandwidth with the feedback equal to FHF minus FLF. Upper cutoff frequency minus lower cutoff frequency. Therefore, the bandwidth is increased, gain reduced. This is frequency response of with the feedback. Gain reduced, input impedance increased or decreased, output impedance increased or decreased based on your type of feedback. Then bandwidth always increased, stability always improved. These are the main features of negative feedback amplifier. Okay. Then based on the input and output connections, it is classified into 4 types. That is topology, feedback topology. Connections, the feedback amplifier topologies there are 4 types of topologies. There. First one, voltage series feedback. Second one, voltage shunt feedback. Third one, current series feedback. Fourth one, current shunt feedback. There are 4 types of topology based on difference. Okay. What is voltage series? Okay, I draw the circuit. This voltage series feedback is also called as voltage amplifier. Is also called as voltage amplifier. This voltage shunt feedback amplifier is also called as resistance amplifier. Trans resistance amplifier. Then current series feedback is also called as trans conductance amplifier. Current shunt feedback amplifier also called as current amplifier. Current amplifier. There are 4 types of amplifier based on their input and output connections. Okay. First of all, we have to study about voltage series feedback amplifier or voltage amplifier. What is voltage amplifier? The input is Vin and output is Vout. Both are voltage, then it is called as voltage amplifier. Okay. Now I am going to draw the circuit for voltage amplifier. Okay. Voltage series feedback amplifier. Okay. This is a amplifier. This is amplifier gain A amplifier. This is feedback network. Its feedback factor is about beta. Now I am going to connect this one output with the input. This is voltage. Okay. First word denote as sampling. Voltage sampling, and the second word denote as mixing. Series mixing. Okay. Voltage. What is voltage? That is parallel. Voltage should be always taken across the output. Okay. This is voltage and series mixing. That's why this is series. Voltage series. The output sampling. First one sampling parallel with respect to load. This is RL load voltage series. This is called as voltage series. Okay. Here this is Vs. Output is V naught. What is it is also called as voltage amplifier. That is what is AF equal to Vout by Vs. This is input Vs. This is output. AF is equal to Vout by Vs. This is voltage sampling series mixing. That is current mixing or series mixing. This is called as voltage amplifier. Okay. Next one, voltage shunt feedback. Voltage shunt feedback. Voltage shunt feedback also called as trans resistance amplifier. Trans resistance amplifier. What is trans resistance amplifier? What is the type of sampling? What is the type of sampling? That is voltage sampling. Voltage sampling means you have to take the out feedback input parallel. Then shunt mixing means okay, you have to draw the diagram for this. Voltage sampling and shunt mixing. Okay, voltage sampling, shunt mixing. This is called as voltage shunt feedback. It is also called as trans resistance amplifier. Here, trans conduction. The input is I current. IS. What is AF? Amplifier gain Vout divided by V by I. Yes, this is trans resistance amplifier. Voltage sampling, shunt mixing. This is called as trans resistance amplifier. Okay. Next one, third one is the current series feedback. It is also called as conductance amplifier. Conductance amplifier. What is the sampling here? See, current sampling. Current should be always taken through the circuit. This is current sampling and series mixing. This is mixing. First word denoted as sampling, second word denoted as mixing. Okay. Current is called as transconductance. Transconductance means I naught divided by Vs. The input should be Vs. Output is I naught. Okay. Here, current sampling and current mixing. This is called as current series feedback amplifier. Current series feedback amplifier also called as transconductance amplifier. Okay. Here the output is I naught and input is Vs. Okay. Then last one, current shunt feedback is also called as current amplifier. Current amplifier I naught by I. So the input should be current source, that is Is. Output should be I naught. The mixing sampling is about current, that is series sampling, and mixing is about shunt mixing. This is called as current mixing. Okay, these are the four types of feedback amplifiers. Okay, then now I am going to introduce what is input impedance of feedback amplifier. Feedback. I am going to introduce input resistance. We have to find out input resistance of feedback amplifier. Either it is voltage series or voltage shunt or current series or current shunt feedback amplifier. Okay. Input resistance. That is called as RIF. RIF means input resistance with feedback is equal to Ri divided by 1 plus A beta whole power plus or minus 1. Okay. The input resistance must be in the input side. What is the input side? This is where amplifier, this is where feedback, this is input, this is output. Okay. In this side, this is sampling, this is mixing. The input is in the mixing side. What are the different types of voltage? Series, voltage shunt, current series, current shunt. First word denoted as sampling, second word denoted as mixing. We have to take this one series, mixing. The second term denoted as mixing. We have to take the mixing side. Therefore, input impedance of current voltage series and current series are, you have to, if it is plus mean that is series mixing. If it is minus 1, it is called as shunt mixing. Okay, that is if for voltage series and current series feedback, the input impedance RIF is equal to Ri divided by 1 plus RIF is equal to Ri into 1 plus A beta. If it is voltage shunt and current shunt, RIF is equal to Ra divided by 1 plus A beta. Based on your sampling, the input impedance may be increase or decrease. Okay. If it is series sampling, if it is series mixing, the input impedance is increased. If the shunt mixing, it is decreased by the factor of 1 plus A beta. Okay. Then next we have to study about output impedance. The output is in the sampling side. This is the sampling one. If it is current series sampling, and shunt sampling. Take it as series sampling and shunt sampling. Okay. If it is plus R naught F, R naught F is equal to R naught into 1 plus A beta, R naught F is equal to 1 plus based on your voltage. Current series and current shunt mean R naught F is equal to R naught into 1 plus A beta, which is voltage shunt and voltage series and voltage shunt. R naught F is equal to R naught divided by 1 plus A beta. If the sampling is current, the output impedance is increased by the factor of 1 plus A beta. If the mixing is voltage or parallel connection, then the output impedance is decreased by the factor of 1 plus A beta. These are the importance of feedback amplifiers. Okay.